Okay, good day guys. In this video, we are going to learn about vectors, where I'll be explaining and showing you guys how to determine the magnitude of a resultant force and direction. So without wasting any time guys, let's quickly take a look at our given question. This question is from one of the previous question papers guys, which is Mechanical Technology, November 2021, grade 12. So let's analyze our given diagram guys. We are given a force diagram, and on this diagram we can all see that we have four forces, right, which are 185 Newton at an angle of 45 degrees, 70 Newton at an angle of 60 degrees, and then 45 Newton going south, and lastly 120 Newton going east, right? So looking at this diagram, we can see that we've got two types of angles, and that's where the examiner tricked 2021 matriculants, because we have the angle of inclination and the angle of elevation, and he knew that most learners can't work with what? With the angle of elevation. So he decided to include it in this problem. But then today we are about to dismantle that mountain. So what are angles of elevation and angles of inclination? Well, the angle of elevation, it's the angle that lies on line y-axis. So in this case 60 degrees is the angle of elevation, because it's lying on what? On line y-axis. And then the angle of inclination, the angle of inclination, it's the angle that lies on line x-axis. In this case, it's going to be 45 degrees, right? But then the tricky part here is that when you work with the angle of elevation, your sign changes, your trig ratios changes. For example, your sine becomes cos and the cos becomes sine. Am I clear? When you work with the angle of elevation, your trig ratios changes. The sine becomes cos and the cos becomes sine. That's where most learners find it challenging or difficult. So to make things easy, let us work with the angle of inclination, right, to avoid changing trig ratios. So if we can check this whole angle here is 90 degrees, right? But then we are given only this portion, which is 60 degrees. So to find the angle of inclination here, which is x, we will say 90 degrees minus 60, and we find this angle to be 30 degrees, right? So now we've got two angles which are angle of inclination. So it's gonna become easy for us to do what? To solve the calculations without changing trig ratios, right? So now that we've clarified that, we can go to the calculations. So the question wants us to do what? To determine the resultant force, the magnitude of the resultant force and direction. But first thing first, I would like us to resolve the components, because we've got forces that are at an angle, right? So let's resolve the component for 185 Newton force, right? So we're gonna have FV, right, for 185 force, which is 185 the sine of 45, right? And then we find it to be, it's 185 the sine of 45. We find it to be 130.81 rounded to the nearest 2 Newton, right? And then FH is 185 the cos of 45 degrees, then equal to, and then 185 the cos of 45 we find it to be 130.81 Newton. So horizontal component and vertical component for 185 Newton force are the same. Reason being that the angle is 45, right? So now let's resolve. These are for 185 Newton force, right? And then now let's resolve the component for what? For 70 Newton force. I'm sorry about that. So FV for 70 Newton force is going to be 70 the sine of 30 equal to 70 the sine of 30, it's 35. It's 35 Newton. And then the horizontal component for 70 Newton force, it's 70. I'm sorry about that. It's cos. It's not sine. It's cos. The cos of 30 equal to equal to 60.22 rounded to 2 nearest place. Therefore, now that we've resolved the component, we can easily calculate the sum of the forces that are going up and some of the forces that are going to the side, up, down, or east or west. So some of the forces, right? Okay, these are for 70 Newton force. Therefore, some of the forces, some of the vertical forces going down positive equal to, okay, before, why am I saying going down positive? Because we already have two forces that are going towards south, and then we only have one force that's going, or that's pointing towards north, right? Therefore, we name direction looking at what? Majority, right? Majority of the forces are the ones that tells us the direction. Therefore, not the whole direction for the component. So equal to, we've got 130.81. I'm sorry, that one is negative. Let me erase it. It's negative, this one. Let me erase it, guys. Okay, let's carry on. I'm sorry about that. We've got 35 Newton and 45 Newton, then minus 130.81. Therefore, we say 35 plus 45 minus 130.81. We find our answer to be minus 50.81 Newton. Therefore, now let's calculate sum of the horizontal forces going west positive. Like I said, we look at the direction based on majority. Therefore, it's gonna be 130.81, then plus 60.22, then minus 120. And then let's put everything into the calculator. It's 130.81 plus 60.22, then minus 120. And then we find our answer to be 71.03 Newton. And then from here, now that we have some of the horizontal forces going down and some of the horizontal forces going west, we can easily get the resultant force, right? Therefore, R squared equal to sum of horizontal forces squared plus sum of vertical forces squared. But then remember, guys, we are not looking for resultant squared, we are looking for resultant, right? Therefore, R, okay, I'm gonna apply the square root for us to get rid of the squared. Therefore, RF equal to, which is horizontal squared, then plus sum of the vertical forces squared. And then from here, let's plug the answers that we got. And then horizontal forces is 70.0. I mean, it's not 70, it's 71. It's 71.03 squared, then plus 50.81 squared. And then from here, our RF equal to 71.03 squared plus 50.81 squared equal to, okay, we find our resultant to be 87.33 rounded to 2 nearest place. So this is our resultant force, guys. That's our resultant force. So from here, let's now determine direction. Let's now determine direction, guys. Okay, let me quickly erase because I'm gonna need space. I'm gonna need some space. So let me erase this portion. Don't think I need it anymore. The only thing I need now is my resultant force and the components, some of the components. Okay, let's carry on, guys. Before determining direction, guys, let us draw the vector diagram, right, and represent the resultant force. So we've got our horizontal component, our vertical component going up, and our horizontal component going west. Then this will be our resultant force. Don't mind my drawing, guys. This will be our resultant force. Therefore R, and then sum of the horizontal forces and sum of the vertical forces, and then that will be our angle or direction. So to get direction, we say theta equal to the arctan of y over x, which is the vertical component over the horizontal component, right? So the arctan into our vertical component, sum of the vertical component, we found it to be 50.81, right? And then this side it's 71.03, and then we can get our angle. Then our angle is arctan 50.81 over 71.03. And then our angle, guys, is 35.58 rounded to 2 decimal place. Therefore this will be our theta, guys. It will be our direction. So that will be our answer, guys. So that's it for this problem, guys. I'll see you in the next video. Thank you.